Alright, if you've ever watched the news, no doubt you've heard a weatherman using the terms cold front and warm front. And these are often used because they're often associated with severe weather that could be coming in. And because of that, it's important to understand the science behind them. So I figured that's what we'll do throughout the course of this video. So what I've drawn right here is a low pressure system. The white lines represent isobars or lines of constant pressure, and your pressure is dropping as you get closer to where you see that blue L. Now around this low, you'll often see this on a weather map. You're going to have your cold front right on, almost stretching to the south of that low. And on your cold front, you know it's a cold front, one, because it's going to be blue, so it's well colored, and then also because you see these little blue triangles right there. Now, where you normally see a warm front is going to be on this side of your low, and you're going to know it's a warm front because, well, it's red and it has these little red semicircles. Now those actually tell you more than you would think. It tells you the direction the front is moving. You could almost think of them as arrows. Like in the example of the warm front here, you could think of them as little arrows like that, and behind it is warm air right here. And then on top of that warm front, you may actually see some things like thunderstorms, tornadoes, but usually that's not where you see your most severe weather. Your most severe weather is usually right along the cold front. You could think of cold air moving in like this, and around the cold front, that's where it's replacing the warm air in front of it, and it's pushing that warm air up the cold front. You get a large amount of cloud formation. That's where you'd get most of your rainfall, your gusty winds, and lots of other features that are important in terms of weather. Now, to understand that, I think it's actually easier to look at kind of a 3D picture of it. So we'll just start two new little drawings right here, and we'll look at a cold front first. So let's say you have some warm air right here. And then we're going to say that some cold air is going to be moving in to replace that warm air. And that might be a bit steep. So I'm actually going to redraw that. Usually it's about like that. And this is going to be your cold air. And then right along that boundary is going to be your cold front. So you have cold air moving in, replacing your warm air. Now what's going to happen to the warm air is it's going to rise up like this. Now, why is it going to rise up? Well, it all comes back to density. Warm air, typically less dense than cold air. So as that cold air moves in, you can almost think of it as if you're like pushing a rock through sand. The sand is just going to rise up against that rock. The reason this is important, though, is where you get rising warm air, it cools down as it rises up. The atmosphere typically depends on which layer of the atmosphere you're talking about, but you could, for a rule of thumb in the troposphere, you could say that air gets colder as you go up. So as this warm air rises, because it's less dense than the cold air and it's being pushed up, it is going to get colder. As it gets colder, it can't hold as much moisture. So what's going to happen is you are going to form clouds where that warm air has risen up. Now, what's going to happen after that is you're going to get precipitation underneath that cloud. And you're not only going to get that, but you're going to get maybe gusty winds and then a big change in temperature as well. So there's a few different ways you'd know a cold front is coming. The easiest way is just thinking about temperatures. You might be 40 degrees in here, and then just on the other side might be 75 degrees. And this is actually something we saw this week. This Monday was 75 degrees and sunny. We had a cold front move into the central coast, and now our daytime highs are around 48 degrees. Now, one other thing that I want to talk about on this cold front, and I should probably label this. So this is a cold front. Why is it as steep as it is? this is actually my favorite thing that I've learned about a cold front. It has to do with friction. You imagine if you were pouring something that is kind of dense, maybe like pudding or oatmeal, it's not going to just like flow out and be flat like water. It's going to have like this little lip on it. And if you're trying to move it forward, it's going to pile up because of the friction down between the air and the surface. So what I learned today, which I think is a pretty cool fact, is when a cold front is moving fast, you're going to have a steeper boundary, meaning you have all of your clouds being pushed up in the same place. So you're going to get probably more intense weather, but it's not going to last as long. Versus if your cold front is slow moving, like the one we have going into California right now, it's not going to be pushed up as much by friction. It's going to be a bit more gradual, and your clouds are going to form over a longer stretch of space. And because of that, you may pick up scattered showers for a longer period of time, but it most likely won't be as intense. So on a cold frontal boundary, you can get rain, snow, wind, thunderstorms, all kinds of different weather phenomena. So now let's talk about what goes on in a warm front. And this is interesting because it's actually very different than a cold front. You'd think it would be the same mechanism, but it's almost the opposite. So let's first draw the back end of a cold air system. So this is our cold air. You can think of this almost like if we were to draw the back end of that cold front we were just looking at. It's moving this direction, so towards, let's say, the east. And as it is, because of friction, it's actually making like a little tail on that cold air mass. So what's going to happen is our warm air is going to be moving in like this, and it's going to go over the cold air. What you call this is overrunning. It's a perfect term. And what's going to happen here, again, it's rising up over the cold air because it's less dense, because it's warm. And then now, this is where you're going to see your clouds forming. And it's going to be a lot more gradual, so it's not going to be as intense. But you can still see some severe weather. In some cases, you can get thunderstorms, tornadoes. But what I think is the coolest thing that I learned about warm fronts is if you were driving from east to west in this situation right here, you would actually be able to see all kinds of different weather over the course of a very short drive. At first, you might actually even be seeing some snowfall right there where your air is still cold enough. But then, as you continue driving, that precipitation would transition into rain as your air gets warmer, and then eventually you're going to break off into the boundary of cold and warm air and then end up where it's maybe just beautiful weather overall. So hopefully all of that information was helpful to you, and you might understand cold and warm fronts a little bit better the next time your weather forecaster is talking about them. If you have any questions, let me know in the comments and I'll try to answer them. Many more weather educational drawings hopefully to come, and I'm slowly getting better at drawing, so that's good to see, I would say. So hopefully this video was helpful, and thanks for watching.